today's webinar is the Oklahoma DOT storm sewer specification changes and how these specification changes will affect designs for future construction. I'm Kevin Parker. I serve as the Regional Engineer for Advanced Drainage Systems. I cover all of Oklahoma and work every day with municipalities, the state DOT, engineers and contractors, answering technical questions about the products that we serve. Below there is the specification and things for the ODOT pay items. I'll start out with this slide. This is a small elephant's foot, and it represents two meanings here. One, this specification change that has been granted for corrugated polypropylene pipe is it's a small first step, but it is a powerful one. The other reason that I include this slide is for everybody to consider mental conditioning as we go through this. And you may not know it, but in Central Africa, when poachers capture a baby elephant, they'll haul them into their camp and lock iron collars around the rear of their ankles, and they stake those elephants out for about 18 months and hold them within a 6-foot radius. And as that elephant stays there, it becomes completely mentally conditioned to think that it can no longer move beyond that. And after that time, when the elephant's grown, all those captors have to do is attach a small chain around their ankle, and they won't move within a 6-foot radius. And it's because that they've been mentally conditioned to stay in that spot. We all know that the elephant has the power and opportunity to escape, but it doesn't because it's been mentally conditioned. And I think that sometimes we fall into some of those same traps in what we've been exposed to, or you've heard, this is the way we've always done it. In school, in engineering school, we're not taught a lot of thermoplastic design. We learn steel, we learn concrete, but we don't learn a lot about thermoplastics. And I just want everybody to kind of be open to what we have to say and where we're going from here, because what thermoplastics has done to the world we live in has been tremendous. 1951 is significant. The year 1951 is significant both for the state of Oklahoma and for thermoplastic design. You may or may not know this, but polypropylene, the material, was actually invented in Oklahoma, in Bartlesville, Oklahoma, in 1951 by two chemical engineers working for the Phillips Petroleum Company, J. Paul Hogan and Robert Banks. They were trying to develop a way to utilize propylene, which is a hydrocarbon that's given off in the natural gas refining process, and they were trying to make it into an additive for gasoline, and they were able to combine it with a catalyst that created a multi-polymer or polypropylene. And they were awarded their patent, I believe, in 1984 for that, after a lengthy debate about who actually created it first. But so 1951 is when the material was first invented. It really didn't become popular in its usage until the late 50s with the invention of the hula hoop. And from then, today, polypropylene material is used all around us. Car batteries are made out of it, car seats, gas cans, things like that. Lots of things that go into that we use every day that's made out of the material polypropylene. So it is all around us. The ASCE 2013 report card says that there's an estimated $126 billion need for water and wastewater projects by the year 2020. And there has not been a municipality or agency or state that I have seen yet that has that kind of adequate funding. And so really what I am posing today is a value proposition of how and what we can do, options that we have to promote value in our infrastructure. Things that we can do to maybe help close the infrastructure gap. This chart was presented at the ASCE National Convention last year, talking about the ASCE Grand Challenge. And it's what we face as engineers. We're all very well aware of this. The infrastructure need is greater than the available funding. And so the grand challenge is, how do you lower the infrastructure need and make the most of the funding that you have available to address our current infrastructure deficiencies? The ASCE Grand Challenge is defined by this statement to significantly enhance the performance and value of infrastructure projects over the life cycles, reducing life cycle cost of infrastructure by 50% by 2025, and fostering the optimization of infrastructure investments for society. To me, if you want to sum all of this up, we simply must create value. We must create value in the infrastructure that we're installing today so that we don't continue to see the issues that we are seeing right now, and that so our future generations don't face the same challenges that we do. What I today is not meant to be the end all of it's a drop in the bucket of a huge issue. But I do feel like that looking at this, we can take those first steps. So you think back to that baby elephant foot. You take that first step. It is a small step, but it's a step in the right direction. And you take that step, and you keep going, and then eventually, hopefully, we'll be able to close that gap. Specific to ODOT, if you look at the ODOT mission statement, the mission of Oklahoma DOT is to provide a safe and economical and effective transportation network for the people, commerce, and communities of Oklahoma. The talk today, I'm focusing on the economical and effective transportation network. What we can do with the materials that we have available. Traditionally, as Americans, we've always made use of the best materials, or made the best use of materials we have available. And today, this year, marks a new material, innovative material that we have available that we're able to make use of. And I'm going to be talking specifics to this, of how integrates into ODOT, and then also to engineers to integrate it into their plans and designs, where you can use it, where you can't use it. So going back to the idea of value, if you define value, value is a benefits versus cost ratio. You always want the value of an item, you want the benefits to exceed the cost. But if you're going to raise the value, even by 50%, as challenged in the ASCE Grand Challenge, you have to raise the benefits while lowering the cost. And so I'm going to talk to both sides of that equation, both the numerator and the denominator, in what additional benefits are we gaining to prolong the service life of infrastructure, and what strategies do we have at lowering cost, and thus, with a combination of those, getting that 50% increase in value that we're looking for. I do want to mention, you know, a lot of times ADS, we have the reputation of being the plastic pipe company. One thing that maybe not everybody knows is that we are a concrete pipe manufacturing company too. And you can see me, I'm on the in the foreground on the left side, black shirt, at our concrete plant. And so I just want everybody to know that, you know, what I'm saying today is not necessarily geared toward one material over the other. It's the combination and how we can create the best value for our infrastructure. So I'm going to start with just a top 10 value-added benefits of corrugated polypropylene pipe. I really want for you to understand the why. You know, where does the value of this pipe come from, and understand why we would want to design with it and why we want to include it in our designs. And then following this, we will talk ODOT specifics of the how. How do we incorporate it in the designs, and what is the best method to gain the optimum value from the materials. Number 10 is we are in engineered design and acceptance. Our pipe is designed per the AASHTO LRFD Bridge Code, Section 12. And it meets all load ratings for the H20 loading as defined in Section 3 of the Bridge Code. We also have ASTM approval, ASTM specifications as far as pipe material and manufacturing. To date, right now, we have ODOT approval, have FAA approval, Corps of Engineer approval, and later this year we'll have AREMA, which is the railroad approval. So to date, right now, we can drive trucks over the pipe, planes, tanks, and trains is really where we're getting. The number 9, ease of handling is the value benefit. The pipe is lightweight, and it makes it easy to carry around a job site or to install in a trench. It's also safer. When you're dealing with that, you don't have to worry about hurting somebody, especially in deep trench applications. But ease of handling is definitely a value benefit. Longer pipe length is the next one versus if you look at RCP pipe lengths at 8 foot, the joint lengths of corrugated polypropylene are 20 feet. And so overall you're looking at a 40% reduction in the number of joints, which will allow contractors to lay the pipe according to RS means approximately 3 times faster, 2 to 3 times faster than other materials. So from a value cost savings benefit, this allows significant time and labor savings. Additionally, if you can work faster on a job, if you have traffic control and things in place, and you can shorten the number of construction days, then as we all know that is significant in and of itself. So anytime that we can speed things up, and then also just the reduction in joints, you're going to with less joints, even at the same joint performance, less joints are going to have a reduction in I&I infiltration and less of a chance of joint failure. Number 7, the corrugated polypropylene pipe as specified by OkDOT does have a 15 psi sanitary grade joint, so it is a watertight joint, which is very good in, if not excellent, in a storm sewer application. Adaptability. With this pipe material, any custom fittings that may be required can be custom created. So any angle, we regularly supply common mitered angles, but any angle can be custom made. So if there is a project that does have that, it's always an option to be able to create custom fittings. Number 5 is efficient. ADS has 26 manufacturing plants and 50 plus storage yards. In Oklahoma, we have a large storage yard on Reno Avenue in Oklahoma City. And our trucks are equipped with hydraulic lift gates that when we deliver pipe to a job site, we can lower the gate, the pipe rolls into the location that the contractor would like the pipe to be stored, and it is left there until the contractor is ready to install it. So from a contractor's perspective, they don't have to touch the pipe until they're ready to install it. And you'll also notice in this picture that the pipes are nested inside of each other, and this is good because if you have a tight working conditions, a place where you don't have a lot of room to store materials, by nesting those pipes you take up less of a footprint on a job site, which would allow room for other things. Number 4, high pipe stiffness. The pipe stiffness of corrugated polypropylene pipe is high enough that it allows for easier installation and allows the contractor to maintain line and grade, and also easier backfill, so you can haunch the pipe in and backfill effectively. Number 3, the pipe is simple to repair and maintain. If for some reason a pipe is punctured, then you can simply cut out a section and install a watertight coupler fitting so that any repairs or things can be easily made and maintained. Number 2 is the promotion of competition, and when you think about this in terms of that value equation, we all know, and it's not specific to pipe. It's specific. It's asphalt versus concrete. It's any two items that compete within a marketplace. If competition is made and encouraged, you're going to see a reduction in price. And we all know that. We all, you look, and if you encourage competition, then you do see that reduction in price. So looking at this from the benefits versus cost equation, if you can show that reduction in cost, then obviously it's going to raise your value. The number 1 value added benefit is it does supply a solution to a need. Like we said, the ASC has identified a $127 billion need for water and wastewater products infrastructure. And so it does provide a viable solution to a need for that will provide a design service life in excess of 100 years. So we're going to talk specific OkDOT specifications right now. And You see the roadway pay items here. The specification is 613EE, and we have diameters approved from 12 inches through 60 inches. And you also notice there that this pay item is controlled via special provision, and I will talk about each of the special provisions associated with this, and then also thoughts on how these can be incorporated into the design process and the bidding process to be used in projects to foster this value enhanced environment. Special Provision 726-2 gives the specification requirement for the manufacture and performance of corrugated polypropylene pipe. It relates it to AASHTO M330, which is specific to polypropylene, and that is the specification that corrugated polypropylene pipe used in state DOT applications would have to meet that requirement. Special Provision 613-1 is the special provision for polypropylene drainage conduit, and under Section 2 of the materials, you'll see that provide polypropylene pipe conduit that meet the requirements of 726-2, which is AASHTO M330, and then pipes with diameters greater than 60 inches will not be allowed. Construction methods, the significant ones here, one is under laying pipe. We are required to provide a 1 foot of non-flammable in-section metal or concrete, or RCP, for every 6 inches of polypropylene pipe diameter, not including any tapered section of the polypropylene pipe. And so the easy way for me to remember that is it's a 2-to-1. So for a 2-to-1 where 2-to-1 slope is what we're dealing with here, and that's the easy way to remember the non-flammable in-section requirement. Also, joining the pipe. When you connect polypropylene pipe to the non-flammable in-section that consists of metal RCP, you have to install a joint so the connection forms a continuous line free of irregularities in the flow line, and ensure the resulting connection is both soil and watertight. And we'll talk about, I'm going to go into these specifically and how to properly identify this stuff and let everybody know what would happen in the field, and how to call it out on a drainage summary and specify the pay item. Backfill of polypropylene with a minimum of 2 feet of approved backfill in accordance with standard SPB-1 and also the fill height tables, which cover maximum depth. So our minimum amount of cover is 2 feet. Maximum is covered with FHT MPP-1 standard. So when we think about this, I want you to think about this relationship. We've all heard this before. A square is a rectangle, but a rectangle is not a square. And as we go through this discussion, I want you to think about concrete pipe or RCP being the square, polypropylene pipe being the rectangle. Currently in per OkDOT specifications, there are places that you can use polypropylene pipe. There are places you can't use polypropylene pipe. But everywhere that you can use polypropylene pipe, you can use RCP pipe too. And I'm going to talk more about this later and why this is significant and how we can use this to create a bidding scenario that, and a specification scenario that would allow, virtually allow an alternative bid, which ODOT does not currently do for pipe materials. Right now, the only thing ODOT does as far as alternative bids is usually a asphalt versus concrete pavement option, but they're not going to go into specific materials for this alternative bidding scenario, and so I'm going to talk more about that later. But just think that, you know, standard SPV-1 gives the pipe bedding class design table and what type of bedding material would have to be utilized on a specific project. You can see the different types of pipes that are available and then where they can be used. So polypropylene is allowed as a cross-drain application in locations that have an ADT of less than 6,000, or in a storm sewer application. This is under paving. So under paving, ADT less of 6,000, you can do cross-drain or storm sewer. Outside of paving, you can do cross-drain, side drains, and storm sewer. And this table also identifies the types of bedding that is required for each of those applications. So the hardest thing for me when I was going through this was how do you handle the non-flammable end section with polypropylene pipe and meet the 2-to-1 requirements. Well, it turned out that it was is actually very simple, in that most of the side slopes that we design are going to be 3-to-1, 4-to-1, or 6-to-1. So if you take the standard end sections that are called out in ODOT standards, and we'll start with the sloped concrete end section because it would be the easiest. So with this end section, it's basically a cast in place end section, and it is a less than 2-to-1 slope. So it would meet the flammability requirement, but it's also very simple in attaching the pipe in that it's cast in place, and so you would attach it just like they currently do with corrugated metal pipe or even concrete pipe. You just cast the head wall around the end of the pipe. And so that's the most simple one. The other end sections, either a CET or a PCES end section, become a little bit more difficult, but I'll explain how we're able to do that, and how we would connect those other types of end sections is through a Marmac dissimilar pipe coupler. So the Marmac does not have to, this does not have to be included in any pay items that you would include on your plans. These Marmacs, when it comes out to bid, we know that the Marmac has to be there to connect to the end section, and so we would include this with the cost of pipe to the contractor. So really what I'm trying to get at is, with any end section that you currently use, you can still use that end section and specify it the same way that you currently are. The Marmac itself is it's a reinforced rubberized mastic external sealing band with an integrated mechanical compression strap. So it's a rubberized mastic that has an adhesive on it, and then you do these stainless steel bands around each of the pipes, and then you overlap that to seal off the stainless steel so that it doesn't degrade over time, and this will provide that watertight connection that is called out in the special provision. So we tested this. We tested the Marmac connection in our concrete yard and attached it to a piece of pipe and lifted it off the ground. So you can see the strength of that connection is going to far exceed anything that the pipe is going to experience. So the only loads as far as that connection is going to see is probably going to be like a frost heave, vertical uplift, or some kind of load that you would typically see out on the ends of pipes. It's a really good connection, and in that scenario, it probably wouldn't be a bad idea to even include this type of connection for those end sections, so that when you do see frost heave or something, that it's not pushing your end section around, and it does stay in place and in line with the rest of the pipe. PCES connections are very simple for the application and meeting the special provision, in that you just butt the joint up, wrap the Marmac around it, and you make the connection. You can see here, if you look at the dimensions, what's called out in the details, dimension D versus the pipe diameter, you're always going to exceed that 2-to-1 slope. So that's required. So this type of connection, you would specify it on your drainage summary sheet the same as you do right now. So you would call out so many feet of polypropylene with PCS connections and reference the standard just as you would now. Really, the major change as far as engineering design and how you call it out is just, PP versus RCP, and that's really the major change. A CET safety slope is a little bit different in that this slope would typically be brought out to the job site and then a head wall cast in place, but you would have a mitered cut of the pipe material, which is the way it's specified now. The OkDOT standard does require that mitered cut be shop cut, and so they actually show up on the job site already cut, and then this head wall is poured on top of it. So under the scenario of using polypropylene pipe, what you'd simply have to do is whatever material you're going to use, and according to the standard, it can be metal or it could be reinforced concrete, but whatever material is there, you would provide a segment that is miter shop cut just as they currently are, connect it butt joint to the polypropylene pipe, and then the mitered section would meet the flammability in requirement. The standard also does allow precast culvert end treatments or other alternative designs if approved by the engineer, and so that would be on the contractor to submit alternative designs, but it would be virtually, it's still the same as what you're doing now, and would still be specified the same. As far as storm sewer type projects, the main thing to know is that the length of pipe is still the same. It's manhole to manhole runs, but for any storm sewer, we have the ability, in that we also install this pipe in sanitary applications. We have the ability to connect to any type of either cast in place or precast manholes. So any boot connections that you may call out, water stop gaskets, and we can connect both our dual wall and triple wall pipes. So really, virtually, even here, it's the same. Everything is the same here between current, RCP, current design, and us. So going back to the idea of RCP being the square, polypropylene being the rectangle, and how we create this bidding scenario. As I mentioned earlier, the DOT doesn't want to do alternative bids. We do have some municipalities that take advantage of that type of scenario and have had success with directly pitting each product against each other. And so to get around that with ODOT, what I would suggest and a solution to that is, if you have a situation where the rectangle will work, knowing that the square will work there also, if the polypropylene rectangle works, then specify it polypropylene, and the contractors that deal with it and the distributors that deal with it will know, and it would be easily to distinguish that, okay, RCP also works here, and then they can bid accordingly. And what that's going to do is move out of a post-bid value engineering scenario. It's going to create the competitive bid up front that is going to create the most value for the project as a whole. And so when you move out of if you move post-bid, then you turn into a value engineering, and per ODOT, the way that it's handled now is if the contractor comes with a value engineering proposition, it's a 50-50 split between ODOT and the contractor. So under that scenario, ODOT's only going to gain 50% of the money that it would have saved back. But if we do it up front, if the engineers as a community can all get on board and say, we're going to put this in our plans, we're going to include the pay item, we're going to put it in our drainage summary, then you create a bidding scenario where RCP can directly compete against polypropylene and vice versa. So to walk away, I just want everybody to know that that's where we stand with this product right now. Obviously, over time, as the department becomes more familiar with it, we would hope that the acceptance of it would continue to grow. On the commercial side and municipal side, we've had huge success over the last couple of years, and we continue to see a lot of good things coming out of Oklahoma with this product. So I appreciate you taking the time to sit through this webinar today. My contact information below, so it's Kevin with an A, .parker@ads-pipe.com, and my cell phone number is there. I'm always available, and if anybody needs to get a hold of me, feel free to give me a call.